is on the second row, first column, and so on and so forth. It has m rows, so the mth entry would be a m1. Okay. It would also have other entries. It could have, let's say, it has a 1, 2, indicating that this entry is on the first row, second column. A 2, 2, indicating that this entry is on the second row, second column, all the way down to an entry on the mth row, second column. And we can continue in this particular fashion across, okay, where we go across to the nth column. So the entry would be on the first row, the nth column. On the second row, we can continue across, okay, so that the entry is on the second row, nth column, and so on and so forth. This entry here is going to be on the mth row, and it's going to be in the nth column. Okay, so there's a general matrix A. It's an m by n matrix, and let's say also that B is another general matrix. Okay, and it has the same dimensions. It's an m by n matrix. Okay, so once again, it has entries that have particular positions, where each entry is on a particular row and a particular column. Let's call these entries, let's say B11, that's the entry on the first row, first column. B21, that's the entry on the second row, first column, so on and so forth. This is the entry on the mth row, first column. Continuing, we have B12, this is the entry on the first row, second column. B22, this is the entry on the second row, second column, and all the way down to BM2. Okay. And all the way across we have B1N. All the way across we have B2N, indicating that this entry is on the second row, nth column. And we can continue in this particular fashion, that the entry here, okay, is on the mth row, nth column, to give us the entry BMN. Okay. So in general, if I want to add these two matrices together, A plus B, what we do is we add terms that are on the same rows, same columns together. Okay, so the new matrix, okay, is going to be the matrix where the first entry, okay, this is the entry that's in the first row, first column, is going to be the sum of the entries in the first row, first column from our two operand matrices. So the first entry is going to be A11 plus B11. Okay. The second entry, okay, or sorry, the second entry, which is the entry on the second row, first column, is going to be the sum of the entries on the second row, first column from our two operand matrices. So it's going to be A21 plus B21. And so on and so forth. The entry in the mth row, first column, is going to be the sum of the entries in the mth row, first column from both matrices. So it's going to be AM1 plus BM1. The second column's entries, yeah, is going to be, well, the first entry here is going to be the entry on the first row, second column. So it's going to be A12 plus B12. The next entry in the second column is on the second row, so it's going to be A22 plus B22, okay, and so on and so forth. The mth row's entries on the second column is going to be the entries in the mth row, second column, the sum of them from each matrix, so it's going to be AM2 plus BM2. And moving across, the nth column's entry on the first row is going to be the sum of the nth column entries on the first row of both matrices. So it's going to be A1n plus B1n. The next entry on the second row in the nth column is going to be the sum of the two entries on the second row, nth column. It's going to be A2n plus B2n, and so on and so forth. The nth row's entry in the nth column is going to be the sum of both entries on the nth row and nth column from each matrix. So it's going to be AMN plus BMN. Okay, and this is what the general form of matrix addition looks like. And you can actually see that what's really important is that the dimensions of both matrices that we want to add together must be the same. The resulting matrix that we have is going to have m rows, and it's going to have all the way across n columns, so its dimension is an n by n matrix. Let me just do one final example where we take two matrices and we add them together. Let's say the matrix, let's say F is 2, 3, 4, 4, 7, 2, 1, 3, 8. So this matrix has 3 rows and 3 columns, so its dimension is a 3 by 3 matrix. And let's say the matrix G, okay, is the matrix, it's also a 3 by 3 matrix, and let's say we have 7, 2, 2, 1, 1, 0, 1, 0, 1 as an example. Okay. This is also has 3 rows and 3 columns, so this is a 3 by 3 matrix. So the result is going to be F plus G is going to be the sum of the, I suppose, the individual entries. Okay. So the sum is going to be the first entry on the first row, first column is going to be 2 plus 7. That's 2 plus 7. Okay. The first entry, the first entry here, okay, on the second row, okay, is going to be 4 plus 1. 4 plus 1. The third row's first entry is going to be 1 plus 1. Okay. Okay. On the next column, the second column, it's going to be the first column's first entry. Okay, on the first row, when we add them together, it's going to be 3 plus 2. It's going to be 7 plus 1. It's going to be 3 plus 0. It's now the third and final column is going to be 4 plus 2. Okay, 2 plus 0. And finally 8 plus 1. Okay. To give us a matrix, okay, that looks like this when we add everything together. 2 plus 7 is 9. 4 plus 1 is 5. 1 plus 1 is 2. 3 plus 2 is 5. 7 plus 1 is 8. 3 plus 0 is 3. 4 plus 2 is 6. 2 plus 0 is 2. And 8 plus 1 is 9. And the resulting matrix has 3 rows and 3 columns. It is a 3 by 3 matrix. Okay. So once again, guys, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope this video was somewhat helpful in our understanding of matrix addition, and more importantly, how to perform matrix addition. Okay, thank you.